Here's another example involving the words prime and composite. In this one, it says prove or disprove whether there is an integer n such that the quantity 2n squared minus 5n plus 2 is prime. So again, normally you don't know if this is going to be true or false. So what you want to do is go to a scratch paper and just try some random numbers n. This is an example of an existential statement. So as soon as you find the integer that makes the quantity 2n squared minus 5n plus 2 prime, then you can stop and you can say, hey, the statement is true. If you've tried a bunch of them and you're not getting that the quantity is prime, then you may tend to think that this property is probably false, or this theorem is probably false, and now you will have to do a disproof. In this particular case, the property is actually true, so let's take a look at how to prove this. To prove this existential statement, all we have to do is find the value of n that allows the quantity 2n squared minus 5n plus 2 to be prime. Again, notice I'm beginning my proof with the word proof, and I'm stating what I would like to do in this problem. I'm not just going to throw the number in the middle of the page and move on with my life. I'm going to actually justify every step along the way. I got to keep in mind that n, the number I pick, has to be an integer. I can select 0 because 0 is in fact an integer. And I can substitute it into the given equation, or the given expression rather, to get 2n squared minus 5n plus 2 to become 2 at the end. So when I plug in 0 by direct substitution, I get that the quantity itself simplifies to be the number 2 only. But keep in mind that 2 is prime. So that means that our theorem is actually in fact true, because when we plugged in an integer that was 0, we got an answer that was a prime number, and that's what we needed to show in this particular problem. So notice how at the end of my proof I write down the statement is true or false. I mentioned that in words again to just remind the reader of what I'm doing, and I say that the proof is over by writing the little square or by writing the letters QED.